Okay, in this GeoGebra app, what we are looking at is the collision of three particles. Okay, so you've got three particles of all identical mass, equal distance apart. Okay, and then what you've got to do is find the speeds after each collision are found using the idea of conservation of momentum, which basically says that MUA plus MUB is equal to MVA plus MVB, and then the speed of separation is going to be B minus the final velocity of B minus the final velocity of B of A is equal to the E coefficient of restitution of the approach speed, which is UA minus UB. Okay, so if we start this, okay, so what happens? A hits B. Okay, A will carry on moving. Okay, and let's carry on. And then B will hit C. Okay, so B's changed colour because it's been hit twice. C will move on, and then what happens is that A will catch B, and will B actually hit C again? Okay, but for 0.25 that will not happen. Okay, so if we stop and reset it, you can calculate, you can see all the calculations here. Okay, but for that to happen, we need E to be less than that value, 0.175 for our initial value of U. So let's just move that back so it's less than that. Okay, let's reset it and have a look again. So start again. So the mass will appear on the right hand side. Again, A hits B, B hits C, A hits B, and then you can see B will eventually catch up with C, hopefully by the end. It's very slow. And therefore you can see, B is actually hit C again. Okay, so it's quite an interesting problem. Hope the GeoGebra helps you to visualize it, and you can get the maths looking down the right hand side here. So this has been a video to look at the collision of three identical particles moving in a horizontal straight line. I hope you've understood, and I thank you very much for watching.